This video is going to push electrolysis a little bit further and have a look at the electrolysis of salt, in particular in solution. So, based on the previous video, the electrolysis of a molten salt will just produce two products. So it will give you your aluminium and your oxygen in the case of aluminium oxide. So at the cathode, aluminium will regain its 3 electrons to go back to the solid aluminium, which is a reduction reaction. At the anode, the oxygen will gain 2 electrons to go back to oxygen, and therefore it is oxidation. However, it becomes slightly more complicated when we have a look at a salt in solution. So for example, sodium chloride and water, you don't just have Na plus and Cl minus, you have an OH minus and a H plus from the water there as well. Now there are a couple of rules to remember which one is going to go to the anode and cathode and which one is going to stay in the solution. So at the anode, the simplest molecule is discharged. So out of these two here, hydroxide and chlorine ions, the chlorine is the simplest, so that will go to the anode, turn back into Cl2, the gas, and disappear off. Out of these two, the hydroxide is the simplest ion, so that one will go to the anode, leaving the sulfate in solution, and in this case leaving the hydroxide in solution. At the cathode, it's all based on reactivity, and it's the reactivity compared to hydrogen. So for example, if something is less reactive than hydrogen, it will be displaced. So the copper 2 plus is less reactive than hydrogen, so this will go to the cathode and turn back into copper by gaining 2 electrons. In this case, however, because sodium is more reactive than hydrogen, it will be the hydrogen that will go to the cathode. So your half equation would be H plus an electron goes to H2, should then need balancing. Okay, so it is the most reactive that stays in the solution, and the least reactive that goes to the cathode. So based on that theory there, in this reaction here, because sodium is more reactive than hydrogen, hydrogen will go to the cathode there, and because chlorine is the simpler of that and hydroxide, that will go to the anode. This will leave two things in the solution, which is sodium and hydroxide, which will form NaOH, which is an alkali and will turn pH paper purple. So in this reaction here, if you wanted to write the half equations, what you'd do is you'd have a look at what happens at both the cathode and the anode. So the cathode, if you remember, the hydrogen went there, so you started off with H+, you added an electron back, and it turned into hydrogen. Because hydrogen is diatomic, it goes around in pairs, so you need to balance it. So that's at the cathode. At the anode, in this case, it wasn't the hydroxide, it was the chlorine. So you had Cl minus, which went to Cl2 plus your electrons. Now because that's 2 there, you need to balance that, and you need to balance that. There are a couple more examples that you should need to know for the exam. So for example, if you've got copper chloride solution, you have Cu2 plus, Cl minus, OH minus, and H plus. Because copper is the least reactive, that's the one that goes to the cathode. So it'll gain its 2 electrons back and turn back into the copper solid. At the anode, it will be the simplest one out of these two, which is chlorine. So chlorine goes to Cl2 plus 2 electrons, which are taken away, which leaves you with hydrogen and hydroxide, which makes water in the solution. The next example you need to know is copper sulfate in water. So you have Cu2 plus, SO42 minus, H plus, and OH minus. Now again, copper is the one that goes to the cathode. This time at the anode, it's again the simplest one. So because this one is more complex, the OH will go there. And this is slightly more complicated because the OH minus will turn back into H2O and oxygen and your electrons. Now when you work that out and balance it, it works out like that, and I'll go through that with you in a bit more detail another time. So that leaves you in the solution with hydrogen and sulfate, which is sulfuric acid. And the final one is sodium sulfate and water. At the cathode, in this case, because hydrogen is the least reactive, you get H plus E minus goes to H2, which is the gas, which will come off, and then balance it. And then at the anode, again, you'll get the hydroxide, so it's 4OH minus goes to 2H2O plus O2 plus 4 electrons. And in this case, because hydrogen and OH minus has come off, you'll be left with the sodium sulfate still in the solution.